so glad that so many people shown their interest and decided to join the community talk today. Yeah, meanwhile, I would give another minute for the rest of the people who still joining, but take a look at the chat, please. I have shared the, sorry, could you please record the, yes, Nakati, I will. I have just started the recording. Hope it will be recording well. Teams indicates the recording is going on. Yeah, I posted the poll, the short poll in the chat. I will post it again. Please take a look. I just want to see if actually the problem that I want to discuss is recognized one or not. All right, so yeah. Just while we go, just please go through. It's just two simple questions. So yeah. So what I wanted to talk with you on, yeah, again, thanks for joining. I hope it's going to be interesting. So what I wanted to talk, well, and what we wanted to talk about today. Yes, so I wanted to talk about something basic, such as unit testing. And this topic is, in my understanding, is quite actual and still. And I actually just posted this poll to see if this problematic that I'm raising is if it's actual or not, if it's recognized, and wanted to analyze the problem the way I see it and suggest an alternative approach, alternative to traditional plain AAA unit testing with single test class per tested class. Yes, so my name is Konstantin Babi. For those who don't know, so nice to meet you all. I'm a solution architect working in Malaga with you guys. So hopefully we will have chance to meet in faces sooner, but currently we can only do it like this. So because this is not a webinar, this is a talk, I encourage you to join the talk, to ask questions, to give suggestions, comments, etc. This is the benefit of such format of the collaboration, and feel free to use it. It's very much welcome, though I will have to track time because we only have this hour. So I guess we have already lots of people joined, so let's start. Yes, and there is quite a lot of responses already, and actually, you know, you can already see yeah, can you please confirm if you can see my screen? Someone?
I can.
Yes, I can.
Okay, amazing, thank you. So you can see, right? It's really nice. I was a bit anxious to see different results, but you can see that these expectations and reality are often mismatch with the unit test code quality. In particular, I mean modifiability, but let's not go into the terms, and people usually recall this as a code quality, right? So we think that it should be the same as production code, but in reality, we often see it's not as good, let's say. And I agree with that completely. That's actually the reason why we have why I suggested this talk. So let's see. Let me start from example. Yes. So there was a challenge, like for me, one probably of the biggest while preparing this talk, is to give you an example, some tested class that has simple enough interface, though complex enough behavior to expose several, like more than a few trivial scenarios to be tested. So this is the tested class that we're going to consider for the code examples. By the way, all the code examples are going to be available on the GitHub, and the link is in the presentation. I will share it later. And this is basically a homegrown synchronization primitive, an event counter that you can increase, decrease, and wait until it gets to certain count. Yeah, let me just show you that code. So that, yeah. So on one hand, it's fairly simple interface. You increase counter, decrease counter, though it has some low-level programming here, multi-threaded programming. And on one hand, you don't usually test multi-threading, which is why I put this funny slide to excuse for using this example. On the other hand, you definitely want to test this primitive before putting it in production. So why not? Let's try. And yes, so I will go to some tests in the code base. But before even going, I just pasted here a single test. Something I tried to write it conventionally, like what I usually see, the plain AAA, one tested class, one test class, range act assert, something like this. And the problems I can see with the quality or modifiability or supportability of this code are here. Like, it's in order to understand what it does, you need to really read it. Or you need to have a very good naming set up in your team and very thoroughly followed. So it's not obvious, and this approach, it often relies on the quite fragile conventions, like convention naming conventions, the structuring conventions, the comments and line arrangement, and the sometimes regions. And also, even at this level, at single test level, we can already see, like the multiple assert here, which is referred as a bad practice, but usually no one, usually people break it with this plain approach, and I will try to analyze why in a few slides. And this is, to me, this is obviously a design problem, and design problems, they don't usually emerge at a single test or a simple tested class level. They usually emerge at a higher scale. That's why it was a challenge to me. I needed to show something simple enough to fit into the scope of our short talk, and complex enough to show the problem at enough scale. So we will see more problems when we see more tests. And let me show you some more tests, actually. So I tried to write the tests for this entity. Yeah, it's them in the same plain AAA manner, like tested class, tested. Yeah, it works. By the way, why are my tests red? Because I probably was playing with the code and I didn't fix it back. So they should be green. We're gonna get to failures and why I'm showing them in a while. So some plain tests with some utility methods. I'm not gonna get into detail. I'm gonna just try to share like the senses and the problems that might arise with this type of code. Hopefully I don't have to go into details, but again, people, if you have questions, if you have suggestions, concerns, doubts, please raise your hand. That's very much welcome. So we have some utility methods here. We have setup, which is fairly short in this case. And we have the test cases, right? And you have very similar problems to those I already raised, and even more, because now the scale emerges. So we have like the same I've told about, right? The long names that are made by convention, the arrangement by the lines, by maybe regions. Regions are not used here, but on a larger scale, they are used. What is more, you will see that this test is much longer than the tested class. So even on this short example, it's 145 lines versus the 54 lines component. So I think no one would. Yeah, I think you might agree that this is the typical case, and I will also try to outline why I think this happens. And another problem is, how do you actually read this test, especially if it's not your code or it's the code that you wrote 2 months or 3 months ago. You need to read them again, and over time you need to actually read the whole test class practically, or like at least scheme it to understand what tests you have, what business cases, what parts of the functionality of the tested component you have covered. And this is not ideal, I would say. So let me see what else. Yeah, what else? And yes, and why do you need to read this code? Again, because you need to maintain it, you need to extend scenarios, you need to change them, you need to add new scenarios. And often what I've seen is when we have those test classes grow in size, I see them new tests just being thrown into, not integrated into existing cases. They're just thrown into and pile up, and they get grow bigger and bigger and harder to control and then maintain. Furthermore, also we will see usually some code duplication, because if we have a simple case, when we have a single setup per tested class, then we can have this setup extracted on setup level or some utility methods. But then if you have slight differences, you will need to duplicate this setup code in between the tests, and so on and so forth. And how do you see which tests share the common setup, which tests have differences? It's not usually easy. Yes, and again, yeah. For example, here in this code, I have renamed the entity, and I haven't fixed all the names. So some of them are named event count, some are named count event. So over the time, the mess will arise. So yeah, and why this happens? Like, I'm not gonna go too deep into that, but basically, the problem, in my understanding, arises from the mismatch of the design and the domain model. So the testing domain model, you have the tested class or the tested system. You might have multiple setups for this system, and you might have multiple scenarios for this, or cases for this setup, and you might have like multiple asserts per each scenario. And that means that if you go with a plain structure, you inevitably duplicate code. Usually this duplication happens we either extract the setups to some helper methods, or we just copy paste them. We have scenarios also often copy pasted, and validations. We have multiple asserts per test to help this duplication at least a bit. Sorry? Okay, so no questions so far. Or are there any? No. Okay, good. Let me move on. We're moving fast. I was expecting more interaction. Let me check, by the way, the results. Yes, so we can see here like 75% of people agree that the tests should be at least, well, everyone agrees that tests should be at least as good as the tested code, and only single person says that in these projects they usually are, but most like the problem is quite obvious here. So yeah, let me close this. Yes, so basically the problem just arises from the mismatch of the design and the domain model. That's the usual cause of the design problems. So yes, I don't wanna show, and basically again, at this point we could stop. Like, there are ways to address this problem. So one of them is, for example, BDD, and there are existing frameworks to do BDD, and they do it fairly well. And they actually approach the problem very similarly. This one suggested here works. because they design basically matches very well the domain model of testing. What I'm trying to do is do something similar to BDD style, propose a structural approach without having to introduce another environment, another language, and more complexity to your tests. Because usually, well, I only met a few cases when people really needed BDD, which is probably gonna raise some holy wars. I don't want that. I don't doubt the usefulness of it. As for me, I prefer simplification when possible, and I prefer staying with C#, for example, on C# project for testing as well. So this is just one of the possible approaches. It works fairly good. I've used it on several projects throughout many years, and that's what it looks like. Let me just show you what it looks like. And yes, so this is our plain tests. Let me just extend this a bit. Some scenarios. Then you are usually gonna see, and this is the same thing written in the a bit more structured approach. So this is the same scenarios, just structured out, and yeah, something like this. So why this complexity? Again, the answer, the complex answer is because it fits the domain model. It will just seamlessly integrate into this model, and but I will show you like how exactly this this works, right? How it fulfills its goals by eliminating those problems that I shown before. So yeah, let me first let me break something. Yeah, I'm sorry that I started broken, but anyways, let me break something. Let me run the tests, and let me see the difference on the output. So basically, we can see that I just broken the condition in the main functionality in the wait until. This is basically the reason why we have this primitive, and some of the tests fail. The difference, though, is here you normally need to read this code to understand what exactly failed, because you have multiple asserts, you have because of these structural problems that I named before. With this, you basically have a bit more. So let's say this fails on the build server or on TeamCity or whatever, and you have this fail test, and you open it, the stack trace, and you instantly can read the whole story as the stack trace. So yes, given event count when adding then decreasing, then waited for decrease successfully, so decrease didn't appear. And basically you can see, okay, in this concise scope, in this particular setup, when we are adding and decreasing, which is the subset of the setup when we have an event count, only this assert false. So let me actually go in a bit of in some code to show you how it looks like. Yes, so what this approach is like, I'm showing some some facts not really connected between each other, but I want to go a little bit more structured here. So basically, we have, okay, this is our top level. We have a context which contains the setup. It's actually given here. So setup, and we have the test classes that contains this scenario, and we have test methods which contain the assertions, all match one to many here, because they all inherit from each other. And we have a short framework, so to say, or a harness to support this convention. So basically, we have kind of an adapter of this convention to this. In this case, it's an unit testing framework. We can. There is one more available for XUnit. They're very, very short, simple, nothing super hard. It's just a utility, a few utility classes. So what this basically does, it says, okay, call arrange and act of the inheriting classes and call cleanup on the teardown. And usually we going back, we have a context when we can have subcontext inheriting this context, and that clarifies the setup and changes it a bit. And we have the test cases that inherit from this context on the given level that they basically do the case. They semantically, they explain, okay, what are we going to test? And then we have the, like, let me open something more complex. Let's say, okay, how I can read this test. So I have the event count set up for me. Like in real world, that would be something more complex, maybe with some mocks. And I also have some utility methods. And what this particular case does, it only explains this case, right? So it says, okay, within this context, I am doing this scenario, and I'm expecting these and this and these outcomes. And look, they are executed separately. You can currently even execute them in parallel with the recent unit changes, and maybe some other frameworks would support that. And they are tested separately, and that's what you receive. You receive more like, first of all, code reuse, because you can reuse your contexts. You actually inherit from them, and you can reuse and hide or there most of the complexity for your setup. Then simplicity and concise scope, because each scenario, each context has its own responsibility and fairly well explained. You have the much more strict structure that allows you to avoid conventional naming. So because your call stack and your namespaces, they explain the whole story now. Like, as I suggested, give an event count, when adding then decreasing, then waited for decrease successfully. So it tells you the whole story of this scenario that happens. What else? Let me see what other problems we have. Like, because it's a more concise scope in each case, you can see the structure. So let me get back. So you can see the structure of your testing. Like you can see, okay, we have just plain tests for our event count created in this case, because it's given event count. And then we set up a more complex context as a subcontext, and we clarify it, and we have some cases for this. So you have some structure out of the box that allows you to see, to comprehend each piece of each moving part easier and integrate the new cases and scenarios and comprehend just without having to read all the code and keep it all in your head. No more need to rely on comments, on line, blah, 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 because you are now using OOP to design your tests. And yes, so huge names, yes, you still have them, but they are composed of the namespaces trailing each other, and you don't really have to maintain them, in sync with each other. Yes, you have single assert per test, which is amazing. And yes, so now we have like a concise scope that improves readability, better reuse and less code duplication, more uniform naming, which works because you have to maintain each segment of your entity on its own level, and it's just reused by all the inheritors out of the box. So I don't have to advert this OOP, I hope. And yes, it's easier to understand and integrate and maintain in the future. Yes, so failure troubleshooting I shown. So this is the link to GitHub with the examples and with the context base for XUnit and unit. And what about snippets? Like, I will get to that in a while. So far, are there any questions? I know there's a lot of information in the short time, but I need to understand if it's more than less clear, if I need to show in more detail the structure of the approach.
I have a question, Kostya.
Yes.
So I'm concerned about if you use this approach, about the possible issues you can have in terms of readability when the number of test cases scales in time. Because I see that to get the full shape of the test, right, we need to navigate through different classes and childs in the tree, and to understand the final scenario is really complex. You need to go first in the GIF, then span it, then go to the when, then go to the. So it's, if you have a really huge number of different steps, I think it will become a mess. And
well, like what I can say, if you have a complex matter, like a complex testing approach, right, you will have quite a lot of code anyways, right? And you will eventually suffer the structuring and code duplication of those. So as I have shown, like, and what I have also experienced a lot, in order to read this complex test, you need to understand all the cases that you have. And here you can abstract. You can okay, now I understand what this context does, and I don't need to read it anymore for every test, right? And I know all these tests, they belong to this context, so they share the same setup. And I open the single test, and it only has what is related to this scenario, because I know what the context is already. I learned it already. So this way you can actually comprehend the structure of your testing. You have it. It's not hidden in a plain structure as opposed to the plain structure. Your intent, your structure of your testing setup and scenarios, it's revealed. You don't really need to read all of them to understand what you have tested, what you have not, from the business perspective, to understand where to integrate your new cases, if you have them or not. You can comprehend that from looking at the structure, if it's written or designed in a good way. That because of course, if you need to design something, there is more ways to do it wrong, of course. So like with the regular code, if you design it well, design helps. If you don't design it well, it just complicates things. But sorry, Miguel, did I answer your question? I hope I did. I can only say this: practically, the code becomes less. The classes become more. So we have more classes, and I have like the mitigations to this. So practically, yes, you have more classes, and that's the consequence of structuring, because you structure the complex monolithic piece of code into some little pieces, right? So yes, you have more classes, but it's in fact because you have a smaller concise scopes, it's easier to comprehend, and because you have code reuse, it's overall less lines of code, even if you read like that, resulting. So I have seen like a lot less code and a lot easier to understand. Did I answer your question, concern?
Yes, I think you did. Thank you.
So basically, there are some challenges though with this approach. We're gonna get to that in a while, but again, I want to recap on the structure. So basically, we have these base classes, and we have, like, even in the base classes, we have arrange, act, and assert, and usually you have a context inheriting from the base classes, which overrides a range. You see it's overrides. And you have the test classes that override act. It's not exactly, it doesn't exactly have to be like that, but usually that's what you would do within this approach. And then because the base class adapts to the unit, you will have one array, like per each assertion, you will have a range called, then act called, then assert called. And you can code reuse your setups, your contexts by inheriting from them, by clarifying them. And this clarification is also going to be very concise. You don't have to rewrite all the code. You just can use inheritance and clarify and change the things that matter at this level of abstraction. And again, you use the same way. You inherit from the context on the same nesting level and show, okay, this is my scenario here. This is my assertions for this scenario. This is, again, maybe I don't have any scenarios like here. I just want to see, okay, for this, when I have event count and I have it increased once, then if I just wait for it to get null, zero, it never gets zero. Like, it's very easy to comprehend. And I haven't opened this code for a while, and I open it and I have no problem understanding what actually it does. So yes, I have the same structure here in the slides. Shift F5. So, like, again, we have a context base, which act, arrange, and clean up. Assert is a test method, and I inherit context. I can inherit context, and I must test cases are the test classes that inherit from the context on the given nesting level, and assertions are the test methods in these test classes. So just by following this domain model, we actually can see, well, I can say that practically we can see much cleaner, reusable, and maintainable tests. So you only have a choice to believe me or not, and you can try. And I can say, like, yes, with advantages. Just want to go through them quickly. You have like the whole context of the fail test without even having to look at the code. That's, again, from the practical standpoint, I can say that that's how it works. You often don't need to read the test code, having it failed on TeamCity, for example, where you don't have the full control or ability to reproduce this. Higher test granularity, aspects isolation, semantics, reusability, etc. Dry code, modifiability, readability. Yes. On the other hand, there are challenges, right? And first, and the biggest challenge is the people often don't want to try. It's like this, like maybe 10 years ago, there was this leap from using unit testing at all, and people say, okay, we have to write twice as much code, or maybe even more. And then all the studies, prove that even on the midterm run, your productivity raises with unit testing, but still, back in time, people were reluctant to write unit tests at all. And this is and the reason is because they were not used to that. And the same here. What I have seen, people do not want to try this, do not want to change the usual approaches to the plain, unstructured unit testing. And the consequence you have seen, like we had this poll at the beginning, eventually the tests will grow large, uncontrolled, and they will lose the quality and maintainability and readability, etc., etc. So they're going to become mess and swamp very often, especially for the complex projects. And yes, so it's a mind shift. It's not easy to start. Like, it takes some effort to just try. because, and that's like it's a clear consequence of having to do something you didn't do before. Design your test, right? You need to design what is your context, or sorry, what is your setup, what is your scenario. You need to decide that basically. So for example, I will give that example in a while. You might decide that your scenario is not an arrange, but it's act. So for example, I don't know, if you are writing a unit test for IOC container, for example, you might need to do that for some reason. And your act is always the same. It's a build, right? So you just build it, build the outcomes of your IOC container. And then your test case is the range because you just change what you actually, how you configure your IOC container. So in this example, you might decide, okay, I designed it this way. The semantics of my scenario is it overrides act because it's going to be the same act for all the cases I have. And the semantics of my case is it overrides arrange because I changed the setup of my IOC container in each case. And I just want to observe the changes in the outcomes. So what has been registered, what can be resolved, etc., etc. So is this one clear? Is my example? I was speaking too fast, maybe because it's a bit cold here. Yes?
I have a question. You mentioned the scenario when we need to get an answer from the build server because we don't have ability to repro this on the developer environment. But
yes.
Is it good for unit testing? Because we are talking about best practices in unit testing, and as I understand, it's not a best practice.
Because, which one is not the best practice?
You mentioned that. Could you please go back to the previous slide?
Yeah, I think you mean this one, right?
Yes. And you said that sometimes it's possible to get error only from the build server logs. But at the same time, unit testing means that every developer can have ability to run them locally and get the same results.
Yeah, of course.
May we discuss a bit about these practices? Because as I see, a lot of projects doesn't have any border between unit testing and integration testing, and most of unit testing just converts into the integration, and we can get results only from the server in the environment.
Okay, Dmitry, I think I see where you're going from, but this is not why I mentioned this. So yes, of course, you should be able to reproduce the tests, the behavior. Yeah, so I was probably saying that, and probably that's not good. Though you can use this approach for integration testing as well, and we did it as well. So this is one of the possible answers to your question, but it's not the main one. The main one is this: you can comprehend your test harness, your test suite without even looking into the code. This is an example of it. So you can understand what goes wrong without having to first open the code, read it, and run it, right? So this is an advantage. Though the practices that you follow and which exactly are the tests we're talking about, it's a different thing. It's an orthogonal thing. So yes, I agree that unit tests should be unit tests. They should follow first principles, and they should be, of course, run on developer machine without any problem. But you can also use this again for integration testing. And again, it's beneficial if you can see the problem right away. If you can see, like, you can read your scenario by the stack trace without having to run it or open the code. I think it's beneficial, and it's also a sign of being this more maintainable and easy to understand. And yes.
And
yeah,
sorry. Continue.
I was going to say that maybe it's not particularly .NET, but what you propose here is very similar, or I find it at least similar to Mocha, which is a test framework for Node, where you get like a test report that it's very similar to this structure, where you can just read the outcome and you can point to a particular test, but just reading the outcome is like should return, I don't know, 2 when some value. So it's like more readable and easier to understand without, as Kostya said, going into the source code and trying to understand that context. You just read the title and you know what you're doing wrong.
Yes, maybe. Like as I suggested, like I'm not inventing the wheel here. It's a regular OOP code structure, and what I'm trying to suggest is an approach that is proven working in .NET, in C#, in my examples, and try to analyze the problem first. Like I think this is more important to explain that tests cannot be plain; they need to be designed if you expect them to have the same code quality as the production code. And this is just single approach. I haven't seen a better approach. Like, but I don't want to say that there is no other better approaches. Like, for example, for some scenarios, using BDD frameworks would be preferable. Though in a general, I prefer simplicity. I prefer to have like few common classes and just a convention that works, and this is what I'm suggesting. But yeah, of course, there are alternatives. So there is two cases, right? So problem first, and then suggest a solution. And you might go with your own one if you realize the problem. All right, any other questions?
May I add some more here? Actually, in Scala, there is a test framework, Scala test, which provides ability to structure the test in the same way, but without additional classes. And is it a problem of NUnit that it's possible to structure tests only by separating them to classes, or is there any other testing framework for .NET which provides ability? Because it's difficult to go through the classes just to follow the behavior from the beginning to the end, and it takes a lot of time usually.
Again, what kind of behavior are like you laid out a big story here, and it contains several items. So what is your question?
Actually, is it a problem of NUnit, and we can find better framework for structuring the test, or it's the best approach for now for .NET?
I don't think it's a problem of NUnit. It's orthogonal to NUnit. NUnit just executes the tests, and there are of course different frameworks. It's I would say it's a problem of what I'm trying to suggest here is the approach to structuring the problem, to structuring the testing based on the domain model, which means you have a domain, you model it in your code. If you follow the same patterns and the same relations in your code as you have in domain, you are probably going to have better results than if you don't, and you will have to eliminate the gaps in your code with duplications, etc., etc. So I am not familiar with this testing approach in Scala that you're referring to. I'm not sure if it's actually in the scope of our talk. In the .NET, in C#, I haven't met any better approach to structure, though I'm open to see if you guys can share something. I will look at it definitely. I'm interested in this topic. Hope Dima, I answered your question.
Yes.
I have one more question, Kostya.
Yes.
So about code duplication, I have clear vision that given and thens are reusable. But what about, sorry, given and when, but what about thens? What if you have different thens that, what if you have different whens that will have some then statements that will be reused?
Oh, that's an amazing question. I love it. Thank you for that. So with this approach, and again, just because it's OOP, you can define the scope of reuse. So you can here, for example, if you have a common assertion, right, and a complex one, you can scope it to some level of scenario. You don't have to have a static, globally visible utility method, but you can have on certain level on, let's say, okay, in this, what is Okay, in this particular setup, I need to reuse this assert. So I don't want anyone else to be bloated with this publicly visible thing, right? So you can write a utility method on your context, for example, that's going to be visible to all of your subclass of your scenarios and subcontexts as well, and reusable, and not visible up in outside, so to say, because it's not static programming. You have the level of context that you want to apply your reuse. Or if you have some global assertions, like global setups, like this object mothers, like this like orthogonal assertions, let's say orthogonal to your structure of your test that you want to expose globally, then you can do it like with utility classes or something like that. But that's also orthogonal to this structure. You can decide at which level you want to reuse with when you have structure. Did I answer your question, Miguel?
Yes, thank you.
Okay. Sorry, guys. I just want to make sure that I finished all the points here, and we will have like 10 more minutes for Q&As. Yes. So this, like, there's, if you want to try, feel free to try. If you need advice, reach out to me. I will try to help, because I really advocate for this approach. So I would dedicate time to help that. So yes, something you need to do, if you try to structure things that were plain before, unstructured and copy paste nature, probably is going to be a bit more complex at the beginning until you're used to that change, and more files. So for that, the solution we used and my teams used were the snippets. So I just created a few snippets. They are shared in this project as well, to quickly create a context class, test class, and test themselves. So that solves the creation problem. A lot of files is actually, I don't think it's a problem, because it provides you more concise context. And if you have a single case that you are concerned about, you can go assertion up to scenario up to context, and you have it like quite a short chain, and you can abstract out of the others scenarios around. If you have if you need to integrate your case somewhere, you have an overview of your functionality, like, because you have the structure laid out in your solution explorer, and you can easily find, practically, I'm saying from the practical standpoint, so you can easily find where to integrate or change if you have this functionality tested or not, and where to integrate it. Yes, and I think I also mentioned that context is optional. No, this one I didn't, because it's inheritance. You can skip contexts if you don't have one for some reason. You can like decide to override act in context and arrange in the case if you decide, because this is design and you make design decisions, and you have certain testing semantics, and you want to express it in the code. Is basically what this approach suggests. So the design equals decide equals structure. So yes, now I am finished, and we have some time for more questions, guys, if there are any. All right, so I guess there are no more questions, but I'm glad that there were questions. I don't know, I'm missing people in this current conditions. So and this is, I hope it was interesting to you. Also, guys, if you have something to share, again, we haven't met for a while. There's a lot of new people. Let's meet together again. I will help to organize this. Reach out to me if you have something interesting to share, to to talk to with the colleagues, with us about. Please feel free. I will support you and help you, and help preparing, dry running, etc., etc. And it's fun. if you need help with adopting or trying this approach, or you have questions on this and that problem and trying it, or you just need to see if you're doing it well, also feel free to reach out to me. I will help you. And yes, I guess we're done, unless there are any other more questions. There are none. So guys, I was really glad to see all of you. Well, not see, but at least hear some of you. And it was a pleasure. And yes, please don't hesitate, reach out to me. We're gonna meet again.
Thank you, Kostya.
Thank you guys.